We've now talked about normal distributions and standard normal distributions and how to find probability. But most stuff isn't going to be standard normal. As an example, we know that height is normally distributed, and we know that the height of males has an average of 70 and a standard deviation of 4. And let's suppose we want to know the probability that someone at random is taller than 68 inches. How do we find this probability? Well, we can still draw our picture. 70 is at the center, so 68 is somewhere over here. And we want to know the probability to the right because the probability that they're taller. And we can still use the z-table to look this stuff up. We just need to convert to z-scores. So we have our data value minus the mean divided by the standard deviation. And in this case, this is negative 0.5. So we need to look up negative 0.5 in our table. Here's our table. Down the first column, we're going to look for negative 0.5. And along the first row, this was exactly negative 0.5, so we're going to go to 0. 0.3085. Back at our example, 0.3085 is what our table said, and this is always the area to the left. I don't want to know the area to the left, so I need to do 1 minus. And when I do, I get 0.6915. So the probability that a given male is taller than 68 inches is 69.15%. This time, let's try to figure out the probability that a given male is shorter than 72 inches. This time, if I draw my graph, here's 72, and I'm going to be shading to the left. And I still need to find the z-score. 72 minus the mean divided by the standard deviation, in this case 0.5. Moving to my table, we'll go down to 0.5 and over to 0 and get 0.6915. Back at the example, 0.6915 tells us the area to the left, which is exactly what we want. So our probability is 69.15%. This time, I want to know what the probability that a given male is between 60 and 72 inches. So 60 is less than h for height, less than 72. This time I'm going to need two z-scores. The first one, I have 60 minus the mean divided by the standard deviation, which gives us negative 2.5. And then for the second one, 72 minus the mean divided by the standard deviation, which gives us 0.5. And we're going to need to look both of these up. Looking up the first one, negative 0.50 is going to be 0.6915. The other one was negative 2.5, so we'll move over to the negative side, down to negative 2.5 and over to 0. 0.0062. When we looked up negative 2.5, we got 0.0062, and when we looked up 0.5, we got 0.6915. So now we just need to subtract them. 0.6915 minus 0.0062 gives me 0.6853, or 68.53%. Next, we're going to look at something slightly different. This time we're going to deal with women's height. We know the mean is 65 and the standard deviation is 3.5. And this time we want to know what height is going to correspond to the tallest 5% of women. So the idea is I'm looking at this little portion I have shaded here, and I know that this is 5% or 0.05, which means this unshaded region has to be 0.95. So in this case, I'm looking for the z-score. So we need to look up 0.95 in our table. Since the 0.95 corresponds to an area rather than a z-score, we need to try to find 0.95 in the center. And if you look for it, we can find at least something close to it right in here. This is actually halfway between 1.64 and 1.65. Since this was halfway between 1.64 and 1.65, we're going to use 1.645 for our z-score. Converting to raw data, let us multiply this number by the standard deviation and then add the mean. And when we do that, we get a height of 70.76 inches. So anyone taller than that would correspond to the top 5% of women.